This is the video for the Blended Algebra 2 class, Unit 2, which is linear functions. These notes are on graphing lines and inequalities and slope. So if you're really good at this skill, skip this lesson and go right into the lesson 2 notes on inverses. If graphing lines is difficult for you, then we should do this set of notes together. All right, so this top part here says equations of lines are typically written in slope-intercept form. So slope-intercept form is that y equals mx plus b format of a line. In this equation, n is the slope and b is the y-intercept. So those are the important things to know, or the important thing that we're going to be talking about in the set of notes. First, we're just going to be given graphs of lines. We're going to identify the slope and the y-intercept, and then we're going to write the equation. So in problem 1, the b is the first thing we find. That is the starting point, or the y-intercept. And here it looks like we cross the y-axis at 0. Now, to find the slope, you need to pick a second point on the line that crosses right through a nice ordered pair. To calculate the slope, remember, you use the idea of rise over run from a graph. So I start at the y-intercept here. My slope is positive, so I'm going to go up 3. That's my rise, and run over 1. Right, 3 over 1 is the slope. You can also write that as 3. Well, now that I know n and b, I can write my equation. Remember, it's in y equals mx plus b form. So the equation would be y equals 3x plus 0. But the plus 0, you don't have to write it. If you wanted, you could just write y equals 3x. Okay, the second equation here. Same thing, I find the y-intercept to start. That is right here at the value of 1. This time my graph is going down from left to right, so I need to pick a couple other points. There's a few other nice ones on the graph. My slope is going down. It's negative. So that means my rise is going to be going down. Here I went down 1, 2, 3. And my run is always to the right. And I'm running over 5. All right. So to write this equation, it looks like my slope is going to be, or my equation, I'm sorry, is going to be y equals negative 3 over 5x plus 1. All right, the last one here. I'm going to start at my y-intercept. Pick another point on the line. You can pick any points you want. My y-intercept here looks like it starts at 2. And again, the slope is going down. It looks like I go down 1 and run to the right 2. So negative 1/2. The equation will be then y equals negative 1/2 x plus 2. Okay. The next part of this is going to be when you're given an equation and you have to graph the line. You want to make sure that each line is in y equals mx plus b form first. That means the y needs to be by itself. I'm all set here in number 1. Number 1 says y equals negative 3/4 x plus 5. Important information, the b is your starting value. That's the number that's by itself. That is 5. You start at 5. And for this graph, the m, the slope, is the number in front of the x, which is negative 3 over 4. When I graph this line, I always start at the y-intercept, the b, which is 5 here. And for a slope of negative 3 over 4, I go down 3, and the over is always to the right. So again, down 3, right 4. You can go the other direction then. The only other time you'll go to the left is when you go the other direction. And you're going to carefully connect those dots. In number 2, I have 2y minus 6x equals negative 2. I can't graph this one yet because it's not in y equals mx plus b form. So the first thing I need to do is solve this equation for y. I'm going to do that by adding 6x to start to both sides. I have 2y equals. Now, the right-hand side here, the -2 does not have an x. So you cannot combine it with the 6x. They just get written next to each other. And then you're going to divide every single term by 2. I'm going to write the final answer underneath here. We'll have y equals -2 divided by 2 is -1 plus 3x. That is the same thing as writing 3x minus 1. It doesn't matter if the mx part comes first or if the y-intercept, as long as you can identify them. This number that's by itself, -1, that's your starting point, your b. And then the coefficient on x, 3, is your slope. All right, when we start here, we start at -1, and my slope this time is +3. Now, when you're doing rise over run, remember that that's rise up 3, right 1. And anytime you have a whole number, the rise is always, or the run, I'm sorry, is always going to be 1. So once you plot those points, you can connect them on the graph. All right, I want you to try number 3 on your own. I want you to pause the video. I'll work through the problem, but if you're stuck, then you can come back and check your answer. But go ahead, pause the video, try it on your own, and then come back. Okay, for this question, we need to get y by itself, just like the last one. So you're going to start by adding 8 to both sides. Just like the last problem, the 8 doesn't have an x, so you need to just write those two terms next to each other. And now we're going to divide everything by 4. What I get when I do that is y equals x over 4 plus 2. Now for this one, the starting value is 2, that's the number by itself, and the slope, there's a little invisible 1 in front of the x. The slope is 1 over 4. So my starting point here is going to be at 2, that's my y-intercept. And since my slope is positive, I'm going to go up 1, run over 4 to the right. Up 1, over 4. And you can go the other direction and connect the dots. All right, let's flip our paper over. Let's talk about some special lines. We have horizontal and vertical. Okay. A vertical line looks like the problem in number 1. That vertical line cuts through an axis. That vertical line cuts through the x-axis here. Because it cuts through the x-axis, the equation is where it cuts through the x-axis at x equals 2. That is the equation of any vertical line, x equals, because they're always going to go through the x-axis. The slope of a vertical line is called undefined. Our other kind of special line is called horizontal. And horizontal lines cut through the vertical, which is called the y-axis. So because that line cuts through the y-axis, the equation is going to be, again, the location where it cuts through the y-axis, which here is at y equals 4. Now this time, the slope of any horizontal line is going to be 0. Now what I want you to do is use those two problems here as examples to help you try on your own the next few problems. Okay? You're going to write the equation in 1 and 2 and graph 3 and 4. Pause the video and then you can come back and check your answers. All right, number 1 is a horizontal line, so it's very similar to number 2 up in this problem. Since it's horizontal, it cuts through the y-axis, so the equation is y equals. It cuts through the y-axis here at -4. Horizontal lines always have a slope of 0. The second one is vertical, and just like we said above, vertical lines always go through the x-axis. So they're going to be x equals, and the number it goes through, that looks like 7 here. And the slope of all vertical lines is undefined. Now next one, you're given the equation, and you need to graph the line. So this one says we're graphing x equals -7. If you see x equals, it's going to go through the x-axis, which is the horizontal one, at negative 7 here. You need to make a vertical line at negative 7, and then that slope is again undefined. All right, now we have y equals negative 9. This graph is going to go through the y-axis here at 9, all the way up here. It cuts through the y-axis, so it's horizontal, and that graph has a slope of 0. Hopefully you got those right. And we're going to finish our notes today with graphing inequalities. We'll talk about the box here in just a second, but inequalities are these symbols. Less than, greater than, less than or equal to, greater than or equal to. When we graph these, there are some things we need to pay attention to. If you see the less than symbol, you're going to graph with a dotted line, and you're going to shade. Since it says less than, you're going to shade underneath, down, or below the line. When you see the symbol greater than, the second one over here in the box, you're going to also use a dotted line. But for greater than, you're going to shade above the line, or up. Okay. So those two symbols both use a dotted line. If you see the next two symbols here with the line underneath, both of those are going to use solid lines to graph, and we'll see that here in a second. The first one here, less than or equal to, for less than you shade down or below, and the bottom symbol greater than you're going to shade above. Okay. So let's see what this looks like. In example 1, we need to solve this for y because we can't graph it unless it's y equals. To do that, I'm going to subtract 2x from both sides. You get negative y is less than 5 minus 2x. Now y is still not by itself. I need to divide every term by negative 1. When I divide by negative, remember when you solve an inequality and you divide by a negative, the sign here is going to flip. So I now have y is greater than negative 5. This is going to be a plus 2x because a negative divided by a negative is positive. Now we can graph. This y-intercept here, our b, is negative 5. The slope is 2. So from 5, you're going to go up 2, right 1. All right, so I want you to take a second and plot all those points that you can that are going to fit on your grid. Now we need to look at the symbol. It says greater than this time. And greater than is going to match this line of information. It says we're going to use a dotted line. So when you come here, you need to connect those dots with a dashed line like this. And it says you need to shade up. Well, shading up means that, say you put your pencil on the line, pull it up. See this region up here that our pencil went to? That would be above. So that shaded region is called your solution set. That's what the graph has to look like. Now number 2, I have the equation x is less than or equal to negative 6. We just talked about x equals lines. This is a vertical line. If you only have one letter in your equation, y equals or x equals, it's going to be a vertical or a horizontal. For x equals negative 6, that's a vertical line because it goes through the x-axis at negative 6. When I see less than or equal to, that is this row of the box that we filled in. We're going to graph that with a solid line at negative 6. And less than or equal to means I'm going to shade down. Now here, down means I want all the numbers that are smaller than negative 6, less than, that's the symbol. Well, those numbers that are smaller than negative 6 are to the left over here. All right, now there are three problems on the bottom to finish our notes here that you can try on your own. The first two are y equals, the third one is solving for y. Try it the best you can and then come back to the video if you need a little bit more explanation. All right, number 1, y is greater than or equal to 3x minus 2. When I graph this, it's already y equals, so I can start by putting a point at my y-intercept of negative 2. The slope is 3. Remember, that's 3 over 1, which means from that y-intercept, I go up 3, right 1. Up 3, right 1. And we're going to do that a few times in either direction until we run out of room. Now, this is y is greater than or equal to. So if you look at that box right up above, greater than or equal to is this bottom line right here. Greater than or equal to. Greater than means you're going to use a solid line, or greater than or equal to, I'm sorry. We're going to connect this with the solid line. The line underneath the inequality here, that part, that tells you that you're going to have a solid line. And greater than means you're going to shade above the line. So put your pencil on the line, pull it up, and it's going to be pulled up into this portion. That is your solution set. The next line says y is greater than negative 1. I only have one letter. I only have y. So this is going to be a horizontal line. A horizontal line that crosses through the y-axis at negative 1. Because it says y is greater than, there is no line underneath that symbol. So you need to make a dotted line at negative 1. And to shade, it says y is greater than. That means above, bigger. So you want the part of the line that is above, or the part of the graph. All right, finally, number 3. We need to get y by itself here. I'm going to start by moving the x terms to the other side. When I do that, I'll get 3y is less than negative 6 minus 5x. And then I'm going to divide every term by 3 so that I can get y by itself here. Now, I didn't divide by a negative, so I don't have to flip my sign this time. It stays y is less than. Negative 6 divided by 3 is negative 2. And then this fraction, I will leave it as a fraction, negative 5/3 x. That's the line you're going to graph. Now, the number by itself, b, is negative 2. So that's where you're going to start. My slope this time is negative. It is negative 5, right 3. You always go to the right. Now, I don't have any more room to go that way, so I'm going to go the other way this time. Up 5, 3 the other direction. Now, my slope is negative, and the symbol here, less than, does not have a line under it. So you're going to use a dotted line to connect those dots. And the inequality less than means below. So if you put your pencil on the line and drag it down below the line, this is the region you are going to shape. All right, if you need some practicers, practice on this. If you're feeling really good about graphing lines, go ahead and skip to the notes on inverses.